Hello and Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 Advanced Geotechnics Section 1 are going to present to you about the direct shear test in PLAXIS 2D modeling. So our group members are as shown as here. So for the introduction, the investigation of the soil on site must be conducted in prior of any construction, including the building construction or any infrastructure construction. So this investigation of soil will conclude of the field investigation and also the laboratory investigation. So field investigation, it will consisting of such as SPT, standard penetration test, to evaluate the strength of the soil by using the SPTN value, or vent shear test to evaluate the shear strength of the soil. Or these parameters can also be obtained in laboratory testing, such as the triaxial test and also the direct shear test. So in this case, we will focus on the direct shear test. So the direct shear test is conducted to determine the shear strength of the soil by using the shear box inside the laboratory. So when we conducted the test inside the laboratory and the result is obtained, so the value, we can compute the value inside this equation to get the shear strength of the soil. So this is the conventional method, which is we conducted the test inside the laboratory. So in this project, we conducted a direct shear test by using a numerical modeling in PLAXIS. So before starting all the modeling, we need to enter to fill of all the parameters of our soil material.
Okay, for the literature review, direct shear test is a test to determine the shear strength of the soil material, and it's commonly used in geotechnical engineering practice. Direct shear test also one of the most frequent and easiest method for determining the strength of a soil, and it may be done on both undisturbed and also the remolded sample. The value of the angle of internal friction and cohesiveness of the soil involved is necessary for the design of numerous engineering problems such as foundation, retaining wall, slab bridge, pipe, and also the sheet piling. And it also used to quickly predict this characteristic and also the parameter. Okay, so for the shear strength, what is shear strength? So the shear strength is the maximum resistance that structure and material can resist when the load is applied to shearing. So this is parameter Mohr column failure criterion used in evaluating the shear strength. According to the Mohr column, shear strength is determined by three factors, which are: the first one is normal effective stress, which is and then friction angle of the material, which is phi, and the last one is the cohesion of the material. So next is the sample. So there are two types of the sample, which are: the first one is disturbed sample. So disturbed sample is the disturbed soil that not retain their properties during the collection process of the soil. And then disturbed sample also are considered representative of subsurface soil by engineers, except for geotechnical testing that do not rely on the structure of the soil itself. And then the properties of a sample are disturbed, such as the structure, texture, density, natural water, and also the stress condition are disturbed. So this is a disturbed sample. Okay, so for undisturbed sample is the sample that has retained their properties from collection process of the soil. So they also have a high recovery rate within the sample, and it is difficult for the engineer to get the undisturbed sample, and maybe have some disturbed sample at the top and also at the bottom of the line. And it will give the engineer to determine the geotechnical properties of the strength, compressibility, permeability, and also the fracture pattern. And the properties of a sample are undisturbed when the structure, texture, density, natural water content, and also the stress condition are disturbed.
So for proposed soil test, the most suitable test. Direct shear test is to determine the shear strength of cohesionless soil. It is the most suitable test for soil that contains the elements that do not stick together. The test can also be conducted on field or in laboratory, therefore it is convenient for both situations. And then looking into this picture, this is the typical setup for direct shear test. And to the next slide. For designing soil tests in PLAXIS 2D, the objective is to gain better insight in the behavior of soil models and improve quality of model parameters. Okay, so for geometry, the design is 2 blocks. Small is 6 cm times 6 cm. For large, it is 30 cm times 30 cm. For negative interface to allow the blocks to slide in against each other. And then consider 1 meter equals to 1 cm equals to 10 mm in the model for simplification. Next, for parameter, it is hardening soil and drain. For this, coefficient is 690 kN per meter square. This is 635 kN per meter square, and then this is 2070 kN per meter square. For power, it is 0.5. For cc, it is 0.5433. For cs, it is 0.15. For this, it is 0.5. For this, it is 0.664 kN per meter square. For this one, it is 20, and this one is 0. Next, for loading, the initial phase is 0. And then for phase 1, the application of the normal stress equals to 98.1 kilopascal for model 1. And then 196.2 kilopascal for model 2. And it is 294.3 kilopascal for model 3. And then for phase 2, the application of the shear stress by displacement is 0.01 mm per minute.
Hi, Assalamualaikum. My name is Muhammad Yusri bin Sulaiman. Today I will present the model in PLAXIS 2D. For the step and procedures, first is insert the title for the project, and the model is axis symmetry. The element used for this project is 50 noded. The contour is based on sample 2, which is 6 cm times 6 cm, and sample 3, which is 30 cm times 30 cm as shown on the figure. After that, create the borehole and take the curves at 0, 0 and modify the soil layer. Add the material set type for the soil interface as shown in the figure. Second step is the material model that used for this project is hardening soil model. Undrained A is selected for this design based on the parameter that we have, and also selection of color as shown in figure. Then put the parameter from the article that had been listed as shown in the figure. For the third step is create the line load from 0 until 0.3 meter based on a sample on x-axis and y-axis. And then put the line load based on the sample, which is 98.1 kilonewton, 196.2 kilonewton, and 295.3 kilonewton as shown in the figure. For the stage construction, there are 3 phases, which is initial phase, confining phase, and shearing phase. It is required to activate the load before running the analysis as shown in the figure. The line load will turn to blue when it is activated. Fourth step is generate mesh to see the element number and the critical point. After that, select point for curves such as A for the node and K for the stress point as shown in the figure. Click update and calculate the result as mentioned in the figure. When the calculate is complete, view the calculation result. At this time, it will show the maximum value for the stress as shown in the figure. For the fifth step, click the curve manager to get the graph for the sample. At the curve parameters, select point K for the x-axis and y-axis. Choose total Cartesian stress for x-axis and Cartesian total stress for y-axis as shown in the figure. Then it will show the graph for this sample as mentioned in the figure. Lastly, in order to get the data for the graph, split table, and then it will pop up the data as shown in the figure. Select all data, then copy and paste to the Excel software. From the Excel software, it can generate the graph stress versus strain. After that, repeat for the next load and the next sample. Thank you.
I am Abdul Hamizi Abdullah. Today I will explain about result for direct shear test. Our case study, we have used a small shear box which is 6 times 6 cm, and scaping method was used to modify the gradation of the sample for the box. So for the first stage, a constant of compression strain was applied, which is 49 kilopascal, and we have conduct 3 different tests with a different value of vertical stress. So the table show the value of vertical stress. The first one, the test 1 is 98.1 kilopascal, and test 2 is 96.2 kilopascal, and the third one is test 3, which is 294.3 kilopascal. Next, this is our design by using PLAXIS. We have designed 3 models of the direct shear test with a different vertical stress. So the figure show the consolidation stage and the shearing stage for each model. Comparison of the graph for experimental test per article and the numerical simulation by using PLAXIS. So generally, experimentals and numerical simulation have the same behavior from the graph stress versus strain. So increasing the vertical stress in the test, the behavior of the sample changes to be more contractive, and the value of volumetric of strain also increase. In test 1, for the vertical stress is equal to 98.1 kilopascal, both samples were observed dilative. For the test 2, the vertical stress equal to 196.2 kilopascal. The behavior of the sample is dilative, while the numerical simulated by PLAXIS, it look like contractive. In test 3, for the vertical stress equal to 294.3 kilopascal, the lowest sample dilation was observed. What we can conclude from this result, with higher vertical stress, the measure of the maximum shear stress has also increasing trend. Thank you.
So the conclusion for this project is the conventional method by means of the conducting the experiment inside the laboratory will require a lot of time and human labor if compared to the numerical modeling. Also, by using the numerical modeling, we can obtain the result in different conditions without doing so much work, and we can check all the parameters, we can set all the parameters, different parameters in all conditions without having go to the laboratory. So from the result, we have a slight difference between both methods, which is from the journal and also the numerical modeling done by us. So this is made due to the difference in configuration of soil particle during the test. So another factors may be the lack of experience in operating the PLAXIS 2D, which will make the result is slight difference between the journal. So for the recommendation, we recommend to make sure that the handler of the numerical modeling, the one who did the numerical modeling, is able to operate and apply a numerical modeling by using PLAXIS 2D fluidly. In this case, this can reduce the error occurred, and also another recommendation is maybe we can provide the exact same condition for both conventional method and also the numerical method to reduce the difference between the parameters of the soil to obtain the most exact result with both methods. That's all. Thank you.